Hello everyone, this is Mrs. Tipti Kulkarni, lecturer, Department of Physics, KLS Kokte PU College, Belgavi. In continuation with my earlier video from the motion in a plane, 4th chapter, and this is my third lecture from the same chapter. In this video, I am going to discuss few concepts along with the derivations, small derivation. Okay. Now, expression for position vector. We know that position vector meaning and as well as displacement vector. Okay. If the particle is moving from one point to another point, if we draw one imaginary line to that with respect to those 2 points, that is called what? Position vector. We already discussed the types of the vectors also. Unit vector means what? Equal vectors, unequal vectors, parallel vectors or negative vectors, everything we discussed. Okay. Now, suppose if we consider a particle, okay, consider a particle, any one particle, okay, in the plane. Plane means what? X, Y means 2 coordinate system, x axis, y axis. Okay. Suppose the particle is at a P. With respect to origin, if we draw one imaginary line between P and O, this OP is nothing but it is a position vector. Okay. So, particle is at P. With respect to this O, suppose if we draw a line, then OP is equal to R. That R is nothing but position vector with reference to what? Origin. Okay. Now, how we have to write this position vector in the vector form? R is equal to xi plus yj, xi plus yj. X means along x axis, along y axis y. I and j are the unit vectors. Of course, the value is equal to 1. Value of I and j are 1. Along x, usually we express I alphabet, small I, and j for y axis and k for z axis. Okay. Of course, the value is how much? It is 1. But why we have to study that unit vector? Because to understand the direction of the particular physical quantity, right? Now, angle between this r and x axis is theta. Okay. So, OP is nothing but it is a position vector. Okay. So, this vector is splitted into 2 components, 2 rectangular components, or with respect to this position vector, xi and yj both are the 2 rectangular components. We already discussed about this. Bisector, diagonal, resultant vector, all these meanings are same. Okay. So, one bisector or a diagonal is splitted into 2 components, or bisector where we show with respect to the 2 vectors. If we draw 2 vectors, then the bisector is nothing but a resultant vector, and resultant vector always we mark on the diagonal side. Okay. So, I hope you understood this diagram. Okay. R is equal to xi plus yj. Magnitude of the position vector is given by R is equal to square root of x square plus y square. Okay. Where I and j both are what? Unit vectors along x and y rectangular components of R. Now, suppose if the particle is moving in the space, this is xy coordinate system, this is x and y coordinate system. Suppose the particle is moving in the 3 coordinate system, x, y, z, then this is z, k. Okay. How we have to write? R is equal to xi plus yj plus zk. Okay. So, this is about the position vector. Now, next one, expression for resultant of 2 concurrent vectors. 2 concurrent vectors means the vectors which are having the same origin. Such vectors are called concurrent vectors. Now, suppose if AD and AB, both these 2 are the 2 vectors. Where is the resultant vector? Definitely at a bisector or diagonal side. The side AC side is called a resultant vector. So, AD and AB both are what? Both are the 2 vectors. So, AD is equal to A and AB is equal to B. So, both are the 2 vectors at point A. AC is equal to R. This AC is the resultant vector R between A and B. Okay. Theta is the angle between resultant vector R and A. Theta is the angle between what? A and B. Okay. Then alpha is the direction of R with respect to A. Alpha is the angle, or it is the direction between R and A. EC is perpendicular. Suppose if we are drawing imaginary lines, okay. Suppose first what we have to do, after drawing all these lines and mentioning these points, suppose if we draw these lines, imaginary lines, okay, B, C, D, then A, B, C, D, is it not a parallelogram? A, B, C, D is what? It is a parallelogram. Okay. Now, suppose if I extend the line, this C point, suppose if I extend this C point till E and D to E, or CE is perpendicular on AD. Suppose CE or EC is perpendicular on what? On AD. Then we have to extend this D point till E. Then is it not DE? So, CED is a right angle triangle and this is theta. CED is a right angle triangle. Carefully once again you observe all the points and see here ACE or AEC, is it not a right angle triangle? Right? Okay. In parallelogram, opposite sides are equal. AD is equal to BC is equal to small a. AB is equal to CD is equal to B. Opposite sides are equal. Okay. Now, from this parallelogram and as well as from this triangle, we can study what is AC. AC is a resultant vector. Okay. Suppose if we consider AEC triangle, apply the Pythagoras theorem here. After applying the Pythagoras theorem, then AC square is equal to AE square or CE square plus AE square. So, let us study the mathematical part. From triangle AEC, means from this triangle AEC, AC square is equal to AE square plus EC square. AE square plus EC square. Okay. Then what is AE here? Is it not AD plus DE? AE is equal to AD plus DE. Okay. So, next step, AC square as it is, AD plus DE bracket square. Instead of AE, we can write AD plus DE whole square. EC square as it is. This is A plus B formula. Okay. Split according to A plus B formula. AC square is equal to AD square plus DE square plus 2AB means 2AD into DE and EC square as it is. But we know that what is AC? AC is R. Substitute the value of AC instead of AC square, R square, and AD is equal to A, small a. AD is equal to A. So, AD is equal to A square. DE square we do not know, write as it is. AD means A, 2A, this is 2 and this is A. DE as it is plus EC square as it is. According to our convenience, we can call it as this is equation number 1. From triangle DEC, from triangle DEC, is it not a right angle triangle? From this triangle, DC square is equal to DE square plus EC square. Carefully see, DC square, again Pythagoras theorem, DC square is equal to DE square plus CE square or EC square. Okay. So, same step here written. Implies DE square is equal to, this DE square is equal to, if I take this to LHS side, then is it not DC square minus EC square? DE square is equal to DC square minus EC square. Same step, same this step, DE square is equal to what? Is equal to DC square minus EC square. So, you can call it as, this is equation number 2, okay, EC square. Same I wrote here, okay. Next step. From the triangle, from the previous triangle, from this triangle DEC, from this triangle, what is sin theta? What is sin theta? This is angle, this is an angle. Which one is opposite side? CE is opposite side, DE is adjacent side, DC is hypotenuse. Okay. So, what is sin theta from this triangle? Sin theta is equal to, is it not EC or CE divided by DC? Correct? So, same we have to substitute here, EC divided by DC. Then what is EC? Cross multiply. EC is equal to DC into sin theta. Call it as equation number 3 according to our convenience. From the same triangle, I will redraw the same triangle here. D, this is C, this is E, and this is theta. From this triangle DEC, what we can write for cos theta? Cos theta is equal to, is it not DE divided by DE divided by DC, DE divided by DC. Then cos theta is equal to DE, or DE is equal to DC cos theta. So, why we have to study that triangle? Because we don't know still what is EC square and DE square. Okay. Now, we understood from the triangle DEC what is EC and what is DE. Okay. You can call it as, this is equation number 4. Equation 2 and 4 in 1. Which one is 1? This is equation number 1, resultant vector R. We have to substitute DE square, DE value, EC square value. Okay. Now, substitute the values of DE and EC. So, R square is equal to A square as it is. DC square minus EC square is nothing but what? It is nothing but DE square. So, already we know this, DE square. So, substitute the value of DE. DE is nothing but DC square minus EC square plus 2A as it is. Okay. Again, instead of DE, what we have to write? DC cos theta, because we know that what is DE. This is DE. Okay. EC square as it is. Now, substitute the values of each side. Okay. R square is equal to A square plus B square plus 2A. This is B. Okay. Because we know the diagram. Okay. We know the diagram. What is DC here? DC is B here. That is the reason we have to substitute DC instead of DC, B, cos theta as it is. Okay. This EC square get cancels. Understood? So, now if we take the square root of this value, then what is the answer? R is equal to square root of A square plus B square plus 2AB cos theta. Because of this cos angle or the cos theta, we can say this equation is cosine equation, or this is also known as a cosine rule. Okay. Either law of a parallelogram, or we can also say that it is a cosine law. Both meanings are same, which is very important for 5 marks, okay, or 3 marks. They may ask for 3 or 5 marks. Okay. So you have to practice this derivation many other times along with the diagram. I hope you understood this derivation. Okay. So next part is from the same derivation another part. Okay, second part. So I split it in two parts. Now if we want to study, that is whatever we have learnt here, this is magnitude of the resultant vector. Now if we want to know the direction of the vector, then to find the direction of the resultant from the triangle AEC, means from this triangle AEC, from the triangle AEC, this right angle triangle, the alpha is the angle between these two, R and A. Then now next one, okay, from triangle AAC, tan alpha is equal to EC divided by AE. Okay, from this triangle, what is tan alpha? Tan alpha means, or tan theta, or tan of angle, any angle, is what? Opposite upon adjacent side. Which one is opposite side here? From this triangle AEC, this AC is a hypotenuse, okay, AE is adjacent side, and CE or EC is what? EC is a opposite side. So this is angle, this is an angle. So opposite upon adjacent side, CE divided by AE or EC divided by AE. So here tan alpha is equal to EC divided by AE. But what is AE? We know that AE is equal to AD plus DE. AE is equal to what? AD plus DE. Substitute that value here in this equation. EC as it is, tan alpha is equal to EC as it is. Instead of AE, AD plus DE. You can call it as equation number 5. So from equations, previous equations 3, 4 and 5, okay, or equation 3, equation 4 in 5, means we have to substitute the value of EC, we have to substitute the value of AD and DE. After substituting the values, tan alpha is equal to DC sin theta, AD plus DC cos theta, okay, because DC is equal, but here DC is equal to B, AD is equal to A, therefore tan alpha is equal to B sin theta, because DC is equal to B sin theta, AD is what? AD is A, so instead of AD, A, and DC is what? Again DC is B, so B cos theta. Then finally alpha is equal to tan inverse, means if we take this tan towards the RHS side, this tan towards the RHS side, then alpha is equal to, that time we have to write inverse. Inverse means minus 1. Tan inverse of B sin theta, A plus B cos theta. Alpha is equal to tan inverse of B sin theta divided by A plus B cos theta. So this is an expression for what? For the direction of resultant vector. Okay, I hope you understood this part also. This is entire, this is in the cosine rule or the law of a parallelogram. Using the law of a parallelogram, we study magnitude of the vector and the magnitude of the resultant vector. So that is nothing but what? This R is equal to square root of A square plus B square plus 2AB cos theta. This is the magnitude of the resultant vector, and this is the resultant of the direction of the resultant vector. This is the direction. Okay. So this is very important derivation. If you need further question and answers from the 4th chapter, please go through the link given below. This is the PUC website link, so you can you will get all question answers, 1 mark, 2 mark, 3 and 5 marks question answers you will get from this website. Thank you.